Okay, here we go. All right. This is, what's today's date? Should we do a date?
6th.
Is today the 6th already?
Yeah.
Is it really?
Yeah.
Is it really?
Yeah.
So today is the 6th, right? It's Thursday, the 6th. What year? 2014. I'm a little tired. I haven't had my coffee yet. What time is it? 8:06. 8:07. Excellent, thank you. That's Daniel from Mexico. Excellent. So I was talking to somebody this morning from my old school, my wife, who works at Ocean Township High School, and her name is Christina, and she's my wife. Not really. She used to cook for me. She used to kind of take care of me, and she'd cook for me, and we'd have lunch together, whatever, but she was never my wife. But anyway, she's a very dear friend of mine. But I call her my wife. Anyway, we have somebody, Matt, you're from Hungary, but you've never been there? You've been all around the world, you lived everywhere?
I was born there.
You were born there. You were born there. Now, when you were speaking to your father the other day, was that Hungarian?
Yeah.
So you speak Hungarian, that's your first language?
Yeah.
Excellent. So you are seriously Hungarian. Magyar, correct?
Yes.
Excellent. That's for Nancy. I have a true Magyar in class. I worked with a Magyar for many years. I actually had a my first Magyar friend was freshman chemistry in college. I had a Magyar friend. And we have Enzo, who has dual citizenship. Is that right? England and France. Yeah. Now, do you speak French fluently?
I speak English better, but I speak French fluently as well.
You speak English better, but you speak French fluently.
Yeah.
Excellent. Daniel, you are from Mexico. You speak Spanish fluently. Now, do you speak Spanish better than English? You do. But you speak English very well. Yeah. Pablo is new to the school. He's getting used to me. I call him a dirty, rotten scoundrel, and he thinks that's some terrible Irish expression or something. But he's new. Pablo's new. You're from Santander,
Yeah.
northern Spain. Excellent. And we have Connor Sullivan.
Australian.
He's from down under. Not under the rug. The next guy lives under a rug. He's like a bug. Joe is a bug. No, I'm kidding. No, Connor is from Australia. He's from Australia. I have 2 Americans in class. I only have 2. I have 3 absents. I'll tell you about them in a second. Then we have Joe, the American. Excellent. Father's ex-military, so Joe's seriously American. Excellent. When you see Joe, simply salute. Okay? All right, now. We have Ahmed. Where are you from, Ahmed?
Egypt.
We have Ahmed is from Egypt. Ahmed's very serious. He's actually doing his work. Are you doing your work?
Yeah.
Ahmed is doing his work as I'm making this video. Unbelievable. And then we have Sarah. Sarah actually lives in the same building as I do, down by the Persian Gulf. Okay, so when she's late, I know it. She's running out the door sometimes, down in the lobby. And Sarah is Libyan, right? No, Algerian. Okay, very good. And then we have from the great state of Missouri. She finds chemistry difficult because it's hard to show her. It's like the show me state. So it's hard to show her an electron. So she's a little bit annoyed at that. And then we have 2 Egyptians. The mad Egyptians are out today. Yeah, Mustafa and Youssef. Yeah, they're always out in the morning. We're rotating classes. And then Annabelle, who just left. She's Canadian. So I only have 2 Americans in here, right?
She left?
She's going back to Canada.
Like, she's gone?
No, like this weekend, I think. Yeah. I think she's taking a 3-day weekend. Yeah, she's gone. Yeah, she's gonzo. She speaks not a lot of English. Her English is infinitely better than my French, but she speaks French. Sometimes it's difficult to hear what she's saying. She has a very heavy French accent, but a lovely person. Okay, and I got yelled at by my wife this morning for not saying hello to Nicole. You know who you are. And Nicole, do me a favor. Would you do me a favor, Enzo, very quickly? See if Mrs. Harvey's in. See if you can get her email. You know, just get her. Just ask her to get her school email. Yeah, just go over there. The environmental science teacher.
I don't know her.
She's in, not across the hall, not the next one down, but the next one down, across the hall.
What should I ask?
For her email.
Okay.
Yes, thank you. That was painful. But anyway, so I'm going to get you her email, and I'll give her your email, and maybe you can kind of like hook up, you know, environmental science talk. Very exciting. And then Deborah, I'll tell you a great story about Deborah. She's wonderful, wonderful. She's teaches chemistry and biology, but I won't tell you now because I want to get started on the video. But I'll tell you the story about Deborah someday. It has to do with a flat tire. It's a great story, and I got yelled at. Not by Deborah, but by someone else. And if I had to do it again, I would do exactly the same. Long story. Anyway, so, and then of course, Dina and Leslie are my, you know, best friends, best buds, you know, Dina and Leslie. Leslie is probably the most, yeah, I'd say she's not, if not the most intelligent woman I have ever met. And Dina's not old enough yet to be that intelligent, but Leslie's been working at it longer. But Dina's wonderful. Anyway, I probably forgot other people that were in that email, but anyway, I will say hello to other people. All right, we have it here. Okay, thank you. This is, and oh, you're wonderful children. Thank you very much. Thank you, Enzo. They're bringing my coffee. I was late this morning. They're bringing my coffee in that I got downstairs. Okay, her name is T. Harvey. That's an underscore, Nicole. Underscore GAA at. It's GEMS. Is that clear? Does that say GEMS? Yeah. It's an E, GEMS, edu.com. And Tony's here. Tony's an environmental science teacher. She's actually going to Amman, Jordan next year. Her contract's done this year, and has a job with her husband and daughter in Amman, Jordan. So I will make sure that you guys hook up. So, all right. What we're going to talk about today is a little bit more stoichiometry, and we're going to do mass, volume, mass, volume, mole volume, etc. Okay, we're going to take a very simple equation though. Okay, now this is the deal with this equation. The equation is simple. Yeah. Equation is simple. But it doesn't matter how complicated the reaction is. It's all the same. It's just the problem would be longer. I would have more complicated elements. Instead of hydrogen H2, I'd have lead 2 nitrate. Instead of hydrogen plus oxygen yields water, and instead of just 3 substances, I'd have 5 substances, but it's all the same. It's all the same. The first, most important thing to know how to do is if I say to you, hydrogen plus water, we'll do a problem as if it's going to be a test, okay? So I say hydrogen plus oxygen, okay? And you have to write the stoichiometric equation. The stoichiometric equation is the one that is a complete, balanced formula equation. So the formula equation, the stoichiometric equation is H2 because it's diatomic, hydrogen, nitrogen, oxygen, chlorine, fluorine, bromine, iodine, when they're in the gaseous states. So now we're going to have to put G there because we know it's a gas, okay? And we're going to say O2. We know that's a gas, okay? Yes? Now the water, I'm going to make a gas. It's generally going to be produced as a gas because the reaction is so exothermic. It gives off so much heat that water's formed, but it's going to be gaseous. When the gas cools off, it'll condense, etc., and come to water. But generally speaking, if you had to say one way or the other, you'd say that that reaction, the water formed as a gas, because so much heat is given off. Okay, you get this explosion, and I'll do that as a demo in class. Yes?
Remember to the other oxygen?
Other oxygen. What does that mean, other oxygen?
Well,
I mean, there's only one here?
Yeah, there's only one on the other side, isn't there?
That's it. Enzo asked a great question. Well, what's going on with that oxygen? Yeah, well, that's the answer. The answer is you've got to balance the oxygens, and then as a result, you've got to balance the hydrogens. Okay, now, the first problem is going to be simply a very, very, very simple one, a mole. Well, the first thing I want to do, now, I want to do something first, and you should always do this the first thing. This is the Darcy Method, okay? The Darcy Method, okay? So you would say 4 grams, right? 2 moles of that is 4 grams. And then I say 32 grams, 16, and then I'd write 36 grams. Right? You get it? So those are what I call the stoichiometric masses. So when you write the complete balance formula equation, otherwise known as the stoichiometric equation, then you write the masses of the indicated number of moles, and you're cooking. Now you have all your constant mass ratios. Okay? Now, I'm going to say the first problem is going to be A. We'll say A is the first problem. A. And the first problem is going to say, if I have 0.2 moles of hydrogen, how many moles of oxygen will I have? How many moles of oxygen will I have? Now, remember with the mole calculations, how many people have seen those that I made? I put them up yesterday. Anybody see them yet? Yeah, very busy, still exam week, okay. Exam 3 week, they have 3 weeks of exams here. It's nuts. It's hard. It's good, but it's a little different from what I'm used to. So you always have to think, what's your constant ratio? Okay, what's your constant ratio? Every problem you have with stoichiometry, think constant ratio. I don't do that in the book. They do it, Xing out and dimensional. They call it dimensional analysis. Some teachers, and that's actually not dimensional analysis. That's just unit label conversions. But people call it dimensional analysis, but that's not dimensional analysis. I know there's that teacher in Kazakhstan's going, no, he's wrong, but it's not dimensional analysis. Okay, so the constant ratio is going to be 2H2 over 1O2 equals 0.2 over X, right? So it's going to be 1 times 0.2, right, is 0.2 divided by 2. So what is 0.2 divided by 2? They're thinking, wow, cool. Oh my God, Pablo just burst into flames. Oh my God, thinking. I'm kidding. Anybody know? It's very early in the morning. Look, guys, you can do it very simply. That's why I made a simple one. What is the relationship between 1 and 2? Isn't 1 half of 2?
Mm-hmm.
So what's half of 0.2?
0.1.
0.1. If you want to use your calculator, you can, because again, this doesn't become very complex, it just becomes longer. You just simply 1 times 0.2 is 0.2, 0.2 divided by 2 is 0.1, put it in a calculator. Enzo, isn't that what you get?
Yeah.
Yeah. So this is going to be, I'll put the answers in red. This is going to be 0.2, right? And this one is going to be, oh sorry, what did I say?
0.1.
0.1, I mean. This will be 0.1, and this will be, you're starting to get it now? You can actually read it. Do you see that 2 there? Isn't that the same as that?
Yeah.
So isn't that going to be the same?
Yes. Yeah.
Okay, right? Isn't that easy? Yes? You could have said 2 over 2 equals 0.2 over, right? Isn't it, you could have said 2 over 2 equals 0.2 over what? Correct? Yes?
Yes.
Okay, so let's get rid of that one. Okay, now let's do another one. Okay, So let's say I want to put a mass here. What's the mass? Given this mole relationship, we're going to do a mole mass problem, right? So what's the relationship between 0.2 and what mass is it? So isn't this the constant ratio? May I help you? May I be your brain just for a moment? I'll be your auxiliary brain. Is that okay? Okay. So wouldn't you say, first of all, you're comparing hydrogen with hydrogen, right? Correct? Yes? So you're saying this is 4, that's 4, right? 2 moles of H2 is 4 grams. How much is that? Right? Right? So what is 0.2 times 4 is what?
0.8.
0.8, good. 0.8 divided by 2. 0.8 divided by 2. 0.4, right? You get that? We'll put the next set of answers in blue. So this will be first of all, this is 0.4 what? Bananas, Spaniards, Mexicans, what? 0.4 grams. Okay, good. So let's make sure we put moles here. MOL is the abbreviation of mole. Yeah? Mole. Good. Yes? Is that good? Yes? Can I erase that now? Can I erase this? Yes? Okay, what else? Let's see. So if I have 0.4 of this, how much of this am I going to have? We can do the same thing, the mole mass, yes? But let's do this mass. In other words, let's compare the mass. See, I did mole. I did mole mass. Yes? Now I want to do a mass. So in other words, I'm comparing hydrogen with oxygen. I know that this is my constant ratio, isn't it? Isn't that what stoichiometry is? It's a set of constant ratios that can be used in proportional relationships to predict products and reactants relative to the chemical reaction proceeding. Yes? So this would be what? The masses would be 4 to 32. That's the constant ratio. 4 to 32, right? So it'd be 4 over 32. We know that's grams, right? Do we have to put G? Yeah, a little shortcut, yeah. And then we'd say 0.4 over X. So what's 32 times 0.4? Get your calculators out. 32 times 0.4 divided by 4. 3.2?
Yes.
So that would be 3.2 grams. Yeah, 3.2 grams. Okay, good. What would this be? We can do it 2 ways. We're going to do it 2 ways. Okay? You know what? Let's go completely crazy today. Let's live on the edge as my buddy Frank, the Frank who did physics, who I taught physics with, as opposed to the Frank, the chiropractor. This is Frank, the physics guy. He used to say live on the edge, you know. Very exciting guy. Very exciting guy. Okay? Okay. So let's do this. Let's do this one 3 different ways. First thing we'll do is we'll just do a mole mass problem. So it's going to be 2H2O. We're going to compare it to itself. We're going to say 36 grams is to 0.2 as what? As X, this is moles, as X is to what? Am I doing this right? Sorry, no. I made a mistake. Sorry. You know, you see what happens when you live on the edge? You kind of make some errors, you know? You live on the edge. So in other words, it's 2 to 36, right? Right? Isn't that the ratio? 2 to 36, right? Yes? Okay. Equals 0.2 to x. What's 0.2 times 36 divided by 2? Anybody?
3.6.
What is it?
3.6.
3.6. Okay, good. 3.6. We'll give it blue. 3.6 grams. Now, let's do it mass, shall we? Let's do it mass. So we're going to say, we're going to leave that there, and we're going to say, okay, we're going to do it with this mass. So we're going to compare O2 with 2H2O. Okay? Is that all right? And we're going to say that it's going to be 32 over 36 equals 3.2 over x. So what is 36 times 3.2 divided by 32? I know you know the answer. Just do it in your calculator anyway. Daniel's very cool, though. He pretends to do it mentally. He'll kind of like it like this. And he'll say, all of a sudden he'll say,
3.6.
3.6 grams. That's what he'll say. And I'm like, wow, he did that mentally. Excellent. So 3.6, you get the same answer, right? Yes? How else are we going to do it? We're going to do it what? I guess that's enough. Okay? Easy? Yes? Yes? All right, so that's that. Now, excuse me. Let's do one more set of problems. Okay? Let's say that I want to know C. We'll do C will be in green. Now, you can't really see green well, can you? We'll do C in red. Okay? You're going to say, what are we going to say? You're going to say 2 liters of oxygen. No, we're not going to say that. No. We're going to say, no, we're not going to say that. We're not going to say that because I want everything to fit. We're going to say this. What volume of hydrogen gas does this mass and this many moles represent? Anybody? No? They're stunned. Absolutely stunned. Absolutely stunned. They're stunned. So let's just, what's the constant ratio? When you think of volume, first of all, you think of STP, and you think of what's the volume of 1 mole?
22.4.
22.4 liters, right? That's Pablo. Excellent. I simply call him the Picasso of chemistry. Excellent. I'm going to call him Picasso. Okay, now. So it would be what? It would be 1, sorry, it'd be 2 moles, right? 2 moles we're looking at? But is that right? Can we say 2 moles or what? It'd be 1 mole because the ratio is 1 mole. So you got to keep your wits about you. Why not 2 moles? You could say 2 moles. You'd have to double it. So we're just going to always think of that ratio in terms of 1 mole. So 1 mole over 22.4 liters equals 0.2 over 22.4. No, what am I doing? Duh. That's not right! You see what happens when you don't have your coffee in the morning? You see what happens? See? Yes, what's the answer? 0.2 times 22.4 divided by 1. We're simply
4.48.
4.48 liters. Is that right? Yes? Yes? Now, we could say volume, or we could say what? mole volume, right? Either one. Yes? Let's do a volume, okay? So it's going to be how much, let's do volume, let's do volume mole, okay? So what would this be? Does that represent 2 moles of this? Does that represent 2 moles? Let's do volume. You guys look confused. So what's the relationship between hydrogen and oxygen? You got to think mole relationship. What's the mole ratio between hydrogen and oxygen? Once you kind of figure this out, the volume problems are actually the easiest. What's the relationship? What's the constant ratio? It's going to be 2 moles of hydrogen per 1 mole of oxygen. Isn't that right? Is that true? Why am I using moles? Why am I using moles? Isn't the constant ratio 22.4 based on a mole? Right, isn't it? So that would be, how many liters of gas are there of hydrogen? 4.48 liters. And what would you get? Shall I do this in my head? 1.24. How did I do that so quickly? I'm really smart. What did I say? Sorry, 2.24. Sorry. Didn't I do that quickly? That was amazing, isn't it? I'm like a walking calculator. How did I do it so quickly? What is 1 times 4.48 divided by 2? What is it?
2.24.
2.24. Now look, guys. You see how the volumes, listen carefully. The volume of all gases, the volume of the same quantity, the volume of the same moles of each gas, given a set of conditions, they're equal. So if I have this is always STP until we do gases. If I have 1 mole of hydrogen and 1 mole of oxygen, what's the volume of each? 22.4, right? If I have 2 moles of hydrogen, is 44.8, right? Yes? So if I have 2 moles of hydrogen and 1 mole of oxygen, what's the relationship between the volume of hydrogen and the volume of oxygen? 2 to 1. Yeah. You get it? So if this is 4.48, that's going to be half, isn't it? Yes? And then what's this going to be?
The sum?
The what?
The sum of them?
No. Oh, I love it. Fabiana, I love it. You have extra credit for making a mistake. The only time that you can get extra credit for making a mistake, Fabiana is trying to say that the volumes are equal. Remember what the law is. It's you're saying equal based on the law of conservation of masses. Yes, this is volumes. Yes? The masses are still conserved. 0.4 plus 3.2 is 3.6, but the volume, you can't use that same law with volumes. Volumes aren't conserved in gases. So you would say what? You would say the same. Remember we talked about? If I have 2 moles of water gas and 2 moles of hydrogen gas, aren't they the same volume? Yeah? If I have 1 mole, it's 1 mole. Same, right? If I have 4.48 liters. If I have 4.48 liters, don't I have the same? 2 to 2. 1 to 1. You get it? You sure? Have you guys had enough?
Yes.
Yeah, that was kind of long. Okay? We'll come back and do another one maybe in a, whatever. We've still got an hour or 45 minutes. Okay? We're off. We'll call this Stoichiometry Part 1? Not very inventive.
To be continued.
To be continued. Excellent. We're off.